On to page 2 of the notes for section 5.2. So there are 3 possible results when solving systems of equations. 3 possible results. Either they are the same line, they are parallel lines, or they're intersecting lines. Same line is where you would have an infinite number of solutions. Parallel lines is when you would have no solution. There is no point that both lines have in common. Whereas if they're the same line, they have all those points in common. So there's an infinite number of solutions. Intersecting lines is where you just get one solution, one ordered pair, x, y. So let's look at this just a little bit longer here, these 3 possible results and when you would get them. You get the same line or infinite number of solutions when x falls out when you're solving, and it leaves a true statement. I'll use some abbreviation here to make it fit. X falls out when solving and leaves a true statement. Parallel lines occur when x falls out when you're solving, and it leaves behind a false statement. Okay, there is nothing that works for those equations, so you must have parallel lines, no point in common, no solution. And of course, intersecting lines occurs when you are able to get an answer. So you are able to get a solution when you're solving. And the book introduces some vocabulary that goes with each of these. I'm just interested in exposing you to this vocabulary. I'm not going to test you on it, but you need to be aware of it so that when it's brought up in instructions and descriptions, it doesn't throw you. You're able to understand what they're talking about. So when it's the same line and there's an infinite number of solutions possible, they call this a dependent system. Parallel lines with no solution, they call this an inconsistent system. Inconsistent. And if they're intersecting lines where you have one solution when you solve the system, they call that a consistent. Again, these are not terms I will test you on, but you do need to be aware of them and familiar enough that you can follow along when the instructions include these as part of what you're supposed to do for your problem sets. And let's look at one of those examples. Number 12 on page 307. Here's our system. Negative 4x plus y equals negative 11. 2x minus 3y equals 5. Both equations in standard form. Just recall the steps here from the earlier page. First, we're going to rearrange or solve for one of the variables, picking either equation. You're going to then substitute that solved equation back into the other one. You'll be able to solve then for one variable. Then you'll use back substitution to solve for the other variable. And of course, we'll check our answer. Most of the time you can do this mentally, but if you run into fractions or decimals, you may have to pull your calculator or work it out a little bit more on paper. And you do want to check those back into both original equations. So step 1 here, both of these would need to be rearranged, so there's not one that particularly stands out, except I see that x doesn't have a coefficient, nothing in front of it in this top one. This one might be a little easier to rearrange. So for step 1, I'm going to add 4x to both sides. So I start with negative 4x plus y equals negative 11. And then I'm going to add 4x to both sides as I rearrange and solve for y. Y equals now 4x minus 11. So that was step 1 taken care of. Step 2 then would be to take that piece and put it into our other equation. So instead of 2x minus 3y, it'd be 2x minus 3, leave some space, equals 5. And we're going to put in the 4x minus 11. So there's step 2. Step 3 then would be to solve this for x. So we'll start by distributing that negative 3. 2x minus 3 times 4x is a minus 12x. Minus 3 times minus 11 is a plus 33. And that equals 5. Combine like terms, 2x minus 12x is negative 10x plus 33 equals 5. Subtract 33 from both sides, I get negative 10x is equal to negative 28. Divide both sides by 10, I get x is equal to a positive 28 over 10. That reduces to 14 over 5. And that solving process represents step 3 of our substitution method. And notice that I reduced my answer here. Step 4 says to back substitute. So you're going to get some fraction practice here. So I'm going to take x, I can put it into either equation. Let's go ahead and put it into the first one. Just again, because y doesn't get multiplied by anything here. So we'll go ahead and rewrite equation 1 here, negative 4x plus y. I'm sorry, instead of y, oh, I goofed that one. Let's try that again. Negative 4 instead of x here, we will plug in our answer that we got of positive 14/5. I'll get it right here in a minute. And we're going to go ahead and solve that for y here. So negative 4 times 14/5 is going to be a negative 56/5 plus y equals negative 11. Add the 56/5 to both sides, I get y equals negative 11 plus 56/5. Utilizing what we know about fractions here, same, we need a common denominator, negative 55 over 5, 56 over 5. That's going to give you a positive 1 over 5. You can check these back in both equations. Negative 4 times our 14/5 plus 1/5 is going to equal your negative 11. 2 times your 14/5 minus 3 times your 1/5. This would be negative 110/5 minus 3/5 here. And you would end up with your answer of 5. It does work in both equations. So we checked our answer here, and this would be a great use of your calculator too, but if you're needing some strength in fractions, push yourself through and try it. This part right here was our step 4 where we did our back substitution. Then of course we checked as well. And then our final answer in set notation would be the ordered pair of 14/5 for x, comma 1/5 for y.